All right, this is chapter 7 summary notes on balancing equations. We're going to be taking a look at the characteristics of oxidation reduction reactions and how to balance electrons. All right, so you see a chart here on your screen that shows a little table of characteristics of oxidation and reduction. And so I'm going to highlight some things here for you. Oxidation always means that it's a process where an element is losing electrons. All right, so if something is losing electrons, then something else must be gaining electrons. All right, so that's the difference there. All right, so reduction is defined as a gain of electrons. Oxidation involves a loss of electrons. All right, in the second column, you'll see that there's some corresponding information there that has to do with things that happen when we talk about organic processes or biochemical processes. Oxidation can be the addition of oxygen, and that used to be the old definition for oxidation. Or reduction can be a loss of oxygen or a gain of hydrogen. All right, so that sounds a little confusing, and we'll deal with that towards the end. But let's take a look and make sure you all know about gaining and losing electrons. You can't have one without the other. So we're going to use this example here of the iron and oxygen as an example and show you how this works. All right, the first thing we can think about are the charges on the substances that are here, because if we're going to keep track of electrons, that would be something to look for. All right, so iron as a solid, I'm going to use my pencil version, has a 0 charge. Oxygen as a diatomic molecule is a 0 charge. Iron within the compound that's over here has a +3 charge. And the oxygen has a -2 charge. If you don't remember why that happens, go back to your nomenclature on binary compounds to see where those charges come from, okay? As a review for yourself. All right, so on the right-hand side, I see that I have actually 4 total irons, and that's what my coefficient of 4 is on the left. I have 3 times 2 oxygens on the right, so I have 3 times 2 is 6 oxygens on the left as well. So the equation is balanced. All right, so now we want to show how the electrons get balanced in processes of oxidation and reduction. All right, so let's write 2 little half reactions here. Iron at a 0 charge, in order to become a +3 charge, it's going to have to lose some electrons to do that. And so if each atom loses 3 electrons that are there, all right, and I have 4 of those iron atoms, how many total electrons is going to be lost? Did somebody say 12 electrons? All right, this is a loss of electrons. All right, so if it's a loss of electrons, I'm going to write oxidation over here. Simply because it's not Q, it's an OX. Oxidation. Okay, so the iron is going to be losing electrons, and I'm just going to write LEO up here. Loss of electrons is oxidation. All right, so let's see what happens to the oxygen. All right, so let's do the oxygen with some blue lines. Oxygen goes from a 0 to a -2, and we have 3 of those. So we have 3 oxygens, and it's going to need to absorb those 12 electrons. All right, because if each oxygen has a -2 charge, and we have 3 times 2 is 6 of them, all right, that means that 12 electrons are going to be needed to reduce the oxygen and form the 6 O2s and a -2 each. Okay, so this is a gain of electrons. All right, so this is called reduction. Reduction reduces the oxidation state. Reduction reduces the oxidation state. It goes from 0 to -2. So if you can remember that, that's one way to know how to do these. Reduction reduces the oxidation state. Okay. And Here's some other pneumatic. If you prefer oil rig, that's up to you. I've been teaching Leo the Lion says "Grr" forever, so that's what I always wind up doing. So gain of electrons is reduction. Reduction reduces the oxidation state, which is your charges on your ions. Okay. All right, so let's take a look at some other half reactions. Identify oxidation and reduction half reactions. All right, let's try this one again as another one. All right, copper sulfate is this pretty blue solution that we see up here on both sides, and then a zinc strip gets put into the beaker and starts to get discolored. And interestingly enough, it becomes orange. It forms an orange coating, and that orange coating is due to pure copper coming out of that solution and attaching itself to that surface. All right, so that's an interesting thing that happens here. All right, so the copper in the solution becomes solid copper. All right, so it's changing from a +2 charge here to a 0 charge here. All right, on the solid copper, because solid copper is neutral. The zinc is going from a 0 charge, I'm going to put it up this way, to a +2 charge in this compound, the zinc sulfate compound. It forms a 2+ charge, or +2 charge. Of course, the sulfate ion is -2 on either side. That doesn't change. All right, and I'll put those charges up here. Okay, so it's important to see why we're calling these things what we're calling them. All right, so let's write these little half reactions. So Cu plus 2. All right, in order to get to Cu0, we have to balance that +2 charge on there. So we need 2 electrons to do that. So we have to add 2 electrons to the copper. And I'm just going to kind of move this over a little bit to get it in here on the same line. Plus 2 electrons makes neutral copper. All right, so where did those 2 electrons come from? They had to come from someplace. Well, take a look what happened to zinc. Zinc went from 0 on the reactant side to a +2 on the other side. And in order to do that, 2 electrons had to be lost. All right, so we have our loss of electrons here. And we have our gain of electrons here for the copper. All right, gain of electrons for the copper, and that's reduction. All right, check. Did the oxidation state go down? +2 to 0? Sure did. And then for the zinc, well, you can't have one without the other, and I keep wanting to make that a Q. I don't know why. All right, oxidation. All right, loss of electrons for oxidation, gain of electrons for reduction. All right, so what am I going to ask you to practice? All right, can you tell me which process is taking place if you see the half reactions? All right, let's try those first. All right, you can do both 3 and 4. Just pause the video and try those, and then come back and check your answers. All right, check your answers on these, and the tin is going from a 0 charge to a +4 charge, so it must lose electrons to do that. So that's oxidation. Both equations in B and C are undergoing reduction reactions, and because their oxidation state is going from a 3+ to a 2+ for iron, a 0 to a -1 for the chloride ion. All right, in the light-sensitive sunglasses, the silver and chloride ions both become neutral compounds, but one is oxidized and one is reduced. All right, it's the chloride ion that's oxidized because it does lose those electrons. The Cl- goes to Cl neutral, 0 charge, and the silver goes from the plus to the 0 charge. So its oxidation state reduces. Okay, that's for that one. All right, and so for our very last little set here, it has to do with the biochemical processes. And I've got a summary for you at the bottom on which one is which, so you can identify these. Methanol is something that was very serious during the turn of the century when alcohol was banned, and a lot of people tried to make their own alcohol at home. and many people did it wrong and distilled methanol instead of ethanol, which killed a lot of people. And how that works in your body is shown here in these three reactions. All right, and you can see if something is oxidized. Let's take a look at each of these reactants and see if they're oxidized or reduced. Remember, oxidation for biochemical processes is a loss of hydrogen or an addition of oxygen. Loss of hydrogen or a gain of oxygen. All right, and then reduction is just the opposite. It's a gain of hydrogen or a loss of oxygen. All right, so again, I'm going to stop the video and you look at the reactants and see if there's what's happening to each one, and then decide if it's undergoing oxidation or reduction. All right, so pause it now. Okay, interestingly enough, all three of these reactants are undergoing oxidation. And let me just remove that part of there. All right, so methyl alcohol, it's losing hydrogen. All right, so that's an oxidation process. The formaldehyde gained oxygen, which again is the definition of oxidation. The formic acid gains some hydrogen or loses oxygen. What is it doing there? All right, it's losing hydrogen. All right, this hydrogen here becomes lost because it becomes part of the water. All right, so it also undergoes oxidation. All right, because the carbon and the O2 stay together, and the H2 and this O2 get together to form the water. All right, so if the formic acid is undergoing oxidation, then the oxygen itself is probably undergoing the reduction because it's gaining hydrogen. Okay, and my last item there says, can you see why drinking methanol can be toxic to humans? And it sure can. It can blind you if you take a small quantity, and it can kill you if you take a large quantity. All right, so oxidation reduction reactions closes out this video.